Good afternoon and welcome to Chegg's live Stoichiometry Office Hours. It is so great to have you, whether it's your first time or you keep coming back for more. My name's Allison. Tonight I will be doing stoichiometry and teaching you all the math and chemistry and how they intertwine. I have TA'd at the University of Louisville for chemistry for about 2 semesters. I have TA'd for regular chemistry, and then I've been a student learning assistant for nursing chemistry, and then I've been a private tutor for organic chemistry and calculus. So I love math, love chemistry. I'm super excited to teach you guys tonight. I encourage you throughout this live stream to ask your questions. So, any questions you have that you went over in class or some homework help that you need, type those in the chat of wherever you're streaming from, whether that be YouTube and Twitch. Sorry, YouTube or Twitch. Let me know those questions. I'd be more than happy to answer them for you right now on the spot so that you can get that help, especially as we prepare for finals. I know a lot of us are going into our finals week, so let me help with that in whatever way I can. Shout out to Chegg for doing this live stream for us. There are live streams all week long. You can check in the QR code in the top left. Such a great way to learn. Chegg has put on a great learning tool for everyone. So let's get started. I've started by preparing a few questions of my own. Again, ask any questions you have while we solve the questions I've created. I'm going to ask you to actively participate. This way, we're all learning, we're preparing for those finals, and we're going to do great. So our first question is a limiting reagent question. I think we started with a limiting reagent question last week. So it's good to get some practice. This is chemistry teacher's favorite type of question. So we have P4 and Cl2 to form PCl5. Already balanced. Again, everything this week is already balanced for you guys because I feel like we need those difficult problems to practice for finals. So don't have to worry about balancing any equations this week. If 12 grams of P4 reacts with 35 grams of Cl2, what is the limiting reagent? That's your first question. Now is your cue to actively participate. Anything you know about this problem, so any way you know how to solve limiting reagent problems, any information you think we'll need, you're going to have 45 seconds to type in the chat and let me know how you would go about solving this problem and the information that you would use. Zoom it in just a little so that we can all see it. All right, you've got about 10 more seconds. Anything you know about this problem and how to solve it, let me know in the comment section or chat section of wherever you're streaming from. All right, 3, 2, 1. So I always like to start limiting reactant problems with a little background of what a limiting reactant or limiting reagent is. You'll hear me use the two interchangeably. That's because they mean the same thing. So a limiting reagent is a reactant or reagent that limits how much product we can make. There's always an excess reactant and a limiting reactant. And together, one of them is going to limit how much product we make, and one there's going to be excess of that allows us to create however much product we can. So it's important we find the limiting reagent to know how much product is formed. So to start out with these problems, I always look for what the problem gives us, specifically numbers and units. So it gives us 12 grams of P4 and 35 grams of Cl2. So I'm going to write that on two separate lines. So that's P4 and then 35 grams of Cl2. All right, that's the first step, writing down what we know. Now we want to figure out what's the limiting reagent. So if you're thinking about how you solve this problem, to solve this problem, we are going to go to moles of our product. So we're going to take each of these grams of reactant to moles of product to see which creates less product. Whatever creates less product is our limiting reagent, kind of goes hand in hand with our definition. So if you said that in the chat, you're absolutely correct. Great job, guys. So we are going to go from grams of P4 to moles of P4. Now you may be saying, why, Allison, are we going to moles? That's because to go to another substance, we always have to go to moles first. We can only convert between substances if we go to that center point, which is moles. So now we're going to want to go to our product. I kind of like to set up everything before I plug numbers in. If that doesn't make sense to you, you can let me know in the chat, and I can do it another way where we can plug the numbers in as we make the conversions. But I think it's easiest to just have a layout before. So then we're going to go from moles of P4 to moles of PCl5. And the same with the bottom, moles of Cl2 to moles of PCl5. Now we have our setup nice and how it should be. And now we just need to find those numbers to plug into those blanks. So we're going to need a conversion from grams of P4 to moles of P4, a conversion from grams of Cl2 to moles of CO2, and then those mole-to-mole conversions. So for the grams to moles, I'm going to give y'all a little hint. You need the molar mass of P4 and the molar mass of Cl2. So I'm going to give y'all about 1 minute to find the molar mass of each. I'm going to be writing on the board how I solve it, just so that we can kind of get an idea if it's been a while since we found molar mass. So we're going to have about 45 seconds. So if you know how to solve this, do it on your own. If you don't, look up here and we will solve it together. So we have 4 moles of P is what that P4 tells us. Then we need to find the molar mass of phosphorus. So the way that we do that is we go to the periodic table, and that number with the decimal at the end, that is our molar mass. So if we go and we see that number with the decimal, it should be 30.97. Same with the bottom, we have 2 moles of Cl times 35.45 grams per mole. And we're just going to multiply across. So if we put in the calculator 4 times 30.97, we get 123.88. And 2 times 35.45 is 70.9. And then we just add the two together. Oops. Just add the two together. Or no, we don't add the two together. I am talking out of my head today. But yeah, those are the 2 molar masses we need. Ignore that. If we are finding P4Cl2 as a whole, we would add them together. But since we're just finding those 2 individual molar masses for that reaction, we don't add them together. Hopefully that makes sense. I know I might have confused y'all there. So if you have any questions on what to do, just let me know and I'd be happy to explain it in more detail. So now let's plug those numbers in. We have 123.88 grams per mole of P4, 1 mole, and then we have 70.9 grams per 1 mole of Cl2. And then we need those mole-to-mole conversions. To get those mole-to-mole conversions, we look at our balanced chemical equation, which is up here, and we plug those coefficients in based on what compound they match. So if we look for PCl5, we see it has a 4 before it, so we can just put a 4 in front of those PCl5s. If we look for Cl2, we see it has a 10 in front of it. And if we look for P4, it has an imaginary 1. No coefficient, just means 1. So now we have all of that plugged in. We are going to put it in our calculators. I'll kind of do a run through of what we put in our calculators in case you haven't seen this setup before. But this is called the factor label method for stoichiometry. Basically, we multiply across the top and we divide everything on the bottom. So in my calculator, I'm going to put 12 times 4 over 123.88. And down here, I'm going to do 35 times 4 divided by 10 times 70.9. That's a lot, but pretty simple to put in our calculators. 70.9 times 10. So now, again, y'all's cue to actively participate. You're going to have 30 seconds. Plug these in your calculator. Let me know what you get. Try to beat me to solving the problem. It's the best way to test yourself and prepare for whatever you have in your semester. All right, for that first one, you should have got 0.387 moles of PCl5. Now keep solving that second one. All right, and for the bottom, we should have got 0.197 moles of PCl5. So, knowing this information, what is our limiting reactant? So we know how much of the product each reagent makes. So what is that limiting reagent? Let's give y'all 10 seconds. Is P4 or Cl2 the limiting reactant? All right, 3, 2, 1. If you said that Cl2 was the limiting reactant, you're absolutely correct. That's because Cl2 creates less PCl5. 0.197 moles of PCl5 is less than 0.387 moles of PCl5. So we'll just say our limiting reaction or limiting reactant is Cl2. Again, if you have any questions, you can type those in the chat about this problem. I'd be happy to go into more detail. If you're just now joining our live stream, it is so great to have you. My name is Allison. I'm so excited to be your hostess tonight. We're doing some chemistry and math mixed together, so I encourage you to ask any questions you have and actively participate, and hopefully you can start preparing for those finals coming up. Our next question, this is kind of like a two-part. So how many grams of PCl5 are formed? So I'll zoom out so you can kind of see everything we've talked about. We know the limiting reactant is Cl2. How many grams of PCl5 are formed? Now, it's your time to actively participate. How will we go about solving this problem? Does anyone have any ideas? I'm going to give y'all about 30 seconds so you can tell me what variables you would use, what numbers you would use, how you would use those numbers, and extra bonus points if you can solve the whole problem in this time. All right, about 10 more seconds. Anything you know about this problem, just dump it out in the chat. We'll see who can get the most correct about this problem. All right, 3, 2, 1. So we're wanting to figure out how many grams of PCl5 are formed. When we want to find how much product is formed from a limiting reactant problem, or in general, we use the limiting reactant to figure out the product. So this one is pretty easy because the way that we went about that first step, we converted to moles of PCl5. So we know how many moles of that PCl5 our P4 and Cl2 will create. And we know that our limiting reactant creates 0.197 moles of PCl5. So we can actually just start with that right there. It's closest to what we're looking for. We always want to choose the number that's closest to what we're looking for if we are ever having to pick one out of many things. So since we're looking for grams of PCl5, we're going to use that moles of PCl5 number. And then we just want to convert to grams. So it should be a pretty easy conversion. We just need to find that molar mass. So I went over with you guys in the first problem how to find molar mass. So I'm going to give y'all 1 minute to find the molar mass of this compound. You can look up on the board if you're wanting some guidance and some help. But if you know how to do it, I encourage you just go full throttle and do it by yourself so that you can practice your learning. So I'll be solving on the board. Again, try to solve this quicker than me. Bonus points if you can solve it quicker than me. I'll be so impressed because I've been doing this for a really long time. No shame in using your calculator. If you can do all these decimals in your head, you are superhuman because I've never seen anyone be able to do this. So I know it's sometimes frowned upon to use a calculator, but in these, you're going to need it. So no shame in it. All right, so I have the answer now up on the board of what that molar mass is. Hopefully, you got that answer. If you didn't, and you're just wanting to know how I got that, type that in the chat. I'd be more than happy to explain it in greater detail. But if we have no more questions about that, we're just going to plug it into the problem. So we got 208.22 grams per 1 mole, and let's just put that in our calculator. So we're doing 0.197 times 208.22. And we got 41 grams of PCl5, which that's great. Hopefully everyone got that answer. Again, if you didn't and you want to go over it in more detail, we can do that. If you're just now joining, it is so great to have you on this live stream. My name's Allison. We are doing mix of chemistry, mix of math tonight called stoichiometry. So any questions you have, type those in the chat. Let me help you learn. And shout out to Chegg for putting together this live stream for us so that everyone can learn. If you check that QR code out in the top left, it has all of our office hours for all week long with all the courses we offer. So we have math courses, science courses, really anything you can think of. Look in that QR code and you'll find our office hours for all week. So our next question is, how many liters of carbon dioxide are produced at 273 degrees Celsius and 1.50 atm, where 6 grams of CH4 combust completely? So this one's a little bit funky, but I think that we can do it. So I'm going to give y'all 45 seconds, figure out how you would solve this problem. Give me what numbers you would use, what equations you would use. You have 45 seconds starting now. Again, anything you know about this problem, dump it out in the chat. We can all check, see where our heads are, and see where we're needing to focus on in this problem. So let me know, and I'd be happy to help you. About 15 more seconds. So anything you know about this problem, let me know. All right, 5, 4, 3, 2, 1. Okay, so first, I said we weren't going to have to balance any equations, but I forgot I put this problem in here, so I lied. I am sorry, guys. But it's pretty easy. It's a combustion. We've done lots of combustion equations. Basically, we need to write the combustion equation of CH4 to CO2. So combustion equations start with a CH compound. We add oxygen, and we yield carbon dioxide and water. Always the same format for a combustion equation. If you see combustion, you know that's your cue to write out this formula. The only thing that might change is the CH4 value. It could be C2H8, C3H10, whatever you can think of. Any CH compound, that number can be. So let's balance. We have one C over here, one C over here, 4 H's. Let's make that 4 H's, 2 O's, and we have 4 O's, so we're going to make a 2 there. And let's just do one more final check. 1 C on the left, 1 C on the right. 4 H's on the left, 4 H's on the right. 4 O's on the left, 4 O's on the right. Our equation is solved and balanced, so that's always a great thing. That was a pretty easy balancing question, but if you want to work through balancing equations in any more difficulty, just let me know and I'd be happy to give us an example of that. So we have this equation, but now what does it mean? We're looking for how many liters of carbon dioxide are produced. So what we need to do is figure out moles of carbon dioxide. Remember, we talked earlier about how to get from any compound to another compound is to find moles. So let's go from 6 grams of CH4 to moles of CO2. We're going to do that in the same format that we did above. So 6 grams of CH4, grams of CH4 to moles of CH4, and then moles of CH4 to moles of CO2. All right, y'all got 30 seconds. We've done a lot of molar mass practice, so 30 seconds to figure out the molar mass of CH4, which is also known as methane. 15 more seconds. What's that molar mass of CH4? Try to beat me to it before I put the answer up. You guys got this. Come on. 5 more seconds. 3, 2, 1. All right. If you put this in your calculator correctly, you should get 16.04 grams per mole of CH4. Then to get that mole to mole ratio, again, we look at those coefficients of the balanced equation. So CH4 has a 1 or an imaginary 1 in front of it. CO2 also has an imaginary 1 in front of it. So now let's just divide 6 by 16.04. And if we put that in our calculator, we should get 0.374 moles of CO2. All right, are we done yet? No, if only it were that easy. So the question asks for how many liters of CO2 are produced at 273 degrees Celsius, 1.50 atm. We can't use that 22.4 liters per mole because we're not at STP, so we are going to have to use PV equals nRT. This is the gas law equation. I'm sure you have heard of it in your chemistry classes. So we're going to use that gas law equation. If you're lost at any point during using this equation or you're like, what is this? Let me know. We can go over it in more detail. But as a quick little rundown, it's just a very basic gas equation to figure out any of these variables. P stands for pressure, V for volume, N for moles, R for this constant, and then T for temperature. So if you have 3 of the variables, you can figure out the 5th because R is just a constant. So now let's plug those numbers in. So the problem tells us that pressure is 1.50 atm. Volume is what we're looking for. Moles we just figured out was 0.374. R is 8.314, not 0. 8.314 atm times liters over moles per Kelvin. Big, long units, but it's important and crucial to the gas law equation. And then T for temperature, we have that it's 273 degrees Celsius, but we need to convert that to Kelvin. So to go from Celsius to Kelvin, it's like a pretty direct conversion. We just had 273.15. So if we put that in the calculator, 273 plus 273.15, we get 546.15 Kelvin. Hopefully making sense. Again, I know this is a lot of numbers, so if you're confused at all during this, let me know. I'd be happy to help. And now let's solve for that question mark. You can also plug in X, Y, whatever you want to solve for. I think a question mark is easiest for chemistry because we use so many different letters. But let's put this in our calculator. We're going to multiply everything on the right. Or actually, I should let you guys solve this. I'm going to give y'all 45 seconds. Solve for the question mark. Hopefully, I'm pretty sure we all know a little basic algebra. So solve for the question mark and let me know what the volume is. 45 seconds, guys. See if you can beat me to solving because I'm trying to solve for it right now. About 20 more seconds. Five, 4, 3, 2, 1. We actually have a huge amount of gas. The answer is 1,132 liters of CO2. That's what you get when you solve for the question mark. It also just so happens to answer the question that the problem is asking, which is how many liters of CO2 are produced. hopefully that made some sense. I know setting up the problem was a little difficult. I think setting up the problem is always the hardest, but if you can set it up, you can solve it correctly. So hopefully that's making sense. Again, any questions you guys have, feel free to type them in the chat. I would love to answer them for you, love to help you prepare for those last tests you're taking or that last homework that you're doing this semester. And I just want to help you learn and truly understand the content. Next question, you have 500 milliliters of 2 molar HCl. You diluted to a final volume of 1.50 liters. How many grams of HCl are present in 250 milliliters of diluted solution? So this one has a lot of different variables and components, but I think that we can solve it. So I'm going to give y'all again 30 seconds, anything you know about this problem, how you would solve it, anything we'll need to use, any equations we need, let me know. And you've got 30 seconds, anything you know about the problem, type it in the chat. All right. Hopefully we've had a few seconds to digest the problem, figure out what we need to do to solve. If you typed something, great job. Let's get started. So we want to find what we're going to use. We're going to use this 500 milliliters of 2 molar HCl, and then to a final volume of 1.50 liters. And then we're also going to need this number right here. So all of our numbers most of the time are important unless you have a kind of mean chemistry teacher and they try to trick you. But most of the time, numbers super important. So first is kind of a two-step problem. We're going to do a dilution problem and then some just plain stoichiometry. So we first need to find out moles, which is molarity. We need to use molarity in the dilution equation, which is M1V1. Oops, wrote that weird. M1V1 equals M2V2. Just to figure out the molarity of that final volume that we're diluting to. Then once we get to that final volume, we can find the grams that are present in 250 milliliters of that final volume. So M1 is just going to be this right here, the molarity of the substance that's not diluted. And then V1 is just that 500 milliliters. So I'm going to plug that in. We have 2 molars HCl. Volume, I'm going to change that 500 milliliters to 0.5 liters just so we can keep units consistent. On the right, we're given V2, which is that 1.50 L. So we'll put 1.50 L, and then we'll do the same as the previous question, just solving for the question mark. So I was just plugging in the variables. I found those in the problem. I would say the students that I TA with, they struggle most with actually finding those numbers and plugging them in. Dilution equations, like the math is pretty simple and straightforward, but actually finding the variables are the most difficult part. So if you had any trouble finding the variables in this problem, let me know. We can do some more practice, but definitely the most difficult part of any dilution problem. So let's plug that into our calculator and solve for the question mark. You've got 20 seconds. All right, 5, 4, 3, 2, 1. Solving for the question mark, you would just divide over by 1.50 L on both sides. You would get the question mark equals 0.667 molarity. Now, here's where the fun part starts because we need to find how many grams of HCl are present in 250 milliliters of diluted solution. So we want to, this is 0.667 is moles per liter. and we have 0.25 liters. The way I did that, just 250 over 1,000 got me 0.25 liters. So I'm going to multiply by that 0.25 to figure out how many moles there are. I know that's a little confusing, but the 0.25 liters is going to dial back the scale because how many moles and grams are present in 0.25 liters as opposed to 1 liter are very different because it's a very different amount of substance. So we're multiplying by 0.25 liters. Let's plug that in the calculator. We do 0.667 times 0.25. We get 0.167 moles. And then it's a pretty simple conversion just from moles of HCl to grams of HCl. So, and what do we need for that? I think we've talked about it enough to know. So does anyone know what numbers we're going to use for the moles of HCl to grams of HCl? We've talked about it a whole lot tonight. That is your hint. You got 15 seconds. What's the conversion from grams of hydrochloric acid to moles of hydrochloric acid? All right, 3, 2, 1. If you said we're using that molar mass, which we find on the periodic table, it should be 1 mole is 36.46 grams of HCl. Hopefully making sense. You can send a thumbs up in a chat or a yes, type yes in the chat. If it's making sense to you, that way I know we can all move on. But let's multiply that in our calculator. So 0.167 times 36.46, we get 6.08 grams of HCl as our final answer. Hopefully that's making sense. If it's not, let me know. That was like a little bit weird of a problem to conceptually think about, but again, those teachers are going to try to trick you, so it's good to know your way about stoichiometry and be comfortable with whatever question you're given. If this isn't coming easy to you right now, there's no need to be worried. Practice makes perfect. I would say it took me a good 3 to 4 months before I felt comfortable solving stoichiometry problems. And it also probably took me another 7 or 8 months before I could look at something and immediately know how to solve it. So definitely takes a lot of practice. Any practice you can get, I encourage you to take. The best way to learn stoichiometry is practice, practice, practice. And this live stream is a great way to start. So we are going to continue on. If you're just now joining, it is so great to have you. If you're needing more homework help, you can scan that QR code in the top left. It's a great resource. All of the resources Chegg offers. And I encourage you, ask questions, use your resources now. Any questions you have about what you went over in class or things you've came across as you're preparing for finals, let me know. And I would love to help you and love to be a resource for you in that. But until we get a few more questions, let's do this next problem, which is zinc plus hydrochloric acid yields zinc chloride plus hydrogen gas. And if 10.5 grams of zinc reacts with excess hydrochloric acid, how many liters of H2 at STP are produced? So I'm going to give you all 30 seconds. Let me know what the key components of this question are, and let me know how you would solve it. Again, bonus points if you can solve the entire problem in the 30 seconds. Your time starts now. About 15 more seconds, guys. So anything you know about that problem in pink, let me know. All right. 3, 2, 1. So the key components that I would underline for this problem is 10.5 grams of zinc, liters is what we're finding, and then STP. That's all going to be super important in solving this problem. So we're given grams of zinc. Our problem ends in liters of H2. So what we need to do is, of course, find that gram to mole conversion of zinc. So let's find that molar mass of zinc again on the periodic table, that number with the decimal point. If you look, it should be 65.38. So Zn equals 65.38 grams per mole. If you have any questions on how I'm finding that number, let me know. But we're going to need to go from 10.5 grams of Zn to moles of Zn. Again, have to go to moles to get from one compound or element to another. And then from moles of Zn, we go to moles of H2. 1 mole of Zn, 65.38, that number we found on the periodic table. And then 1 mole of H2 to 1 mole of Zn. Again, super easy conversion, not doing any wild numbers. Let's put this in the calculator to find our moles of H2. Got 30 seconds. Try to beat me to solving this. Type it in the chat before me to get a virtual high five or a shout out. All right, 5 more seconds. Try to beat me to solving this, guys. All right, 3, 2, 1. You should have got 0.161 moles of H2. Hopefully that's making sense. I just did a multiply across the top and divide across the bottom to get that number. Now I want to go from liters of H2 at STP. Now I want to go from moles of H2 to liters at STP. So I'm going to do 0.161 moles of H2. And since we have that key phrase at STP, we can use that conversion that 1 mole equals 22.4 liters of gas at STP. So 1 mole, 22.4 liters. We can only use this conversion when STP applies. So if it's not standard temperature and pressure, we can't use that 22.4 number. I'm going to give y'all another 20 seconds. Try to beat me to solving this part of the problem. Time starts now. Ten more seconds, guys. 3, 2, 1. If you put this in your calculator, if you put 0.161 times 22.4, you're going to get 3.60 liters of H2 at STP, which answers our question. So great job, guys. Good job to everyone who participated. So if you're just now joining, it's great to have you. We're so happy that you joined this live stream. And I encourage you to ask any questions you have throughout the live stream. I would love to help you. We're almost 2/3 of the way through our time. So rounding up on those last minutes to ask any of your questions. So I encourage you, use this time wisely, get the resources out of it that you can. And we are going to go on to our next problem. So a 0.450 gram of an unknown compound containing carbon, hydrogen, and oxygen is burned in excess O2 to produce 1.10 grams of CO2 and 4.50 grams of H2O. What's the empirical formula? So this one, a little difficult, a little different. We've never done a problem like this before on the live stream, but I thought, what's a better way to start than tonight? When's a better time? So I'm going to give y'all 45 seconds. I want you to brainstorm, use those stoichiometry skills that you've learned to think about how you would solve this problem. You have 45 seconds starting now. "30 seconds, guys. Any ideas you have about this problem, let me know in the chat. No idea is a bad idea, so don't be scared to type your thoughts in the chat. Got about 15 more seconds. Five, 4, 3, 2, 1. So what we need to do first of all is convert our grams of carbon dioxide and our grams of water to moles. So 1.10 grams of CO2. Let me use a different color so we can kind of tell the difference. 1.10 grams of CO2. And then 4.50 grams of H2O, converting both of those to moles. So we have grams and we have moles. Grams and moles. I'm going to give y'all 1 minute. Find those values on your periodic table and solve. And once you figure out those numbers, type them in the chat to lock them in. All right, 3, 2, 1. You should have said 1 mole of CO2 is 44.01 grams. 1 mole of H2O is 18.02 grams. And then let's just divide across to figure out those moles. Same with the bottom, 4.5 divided by 18.02. Again, anything you solve, type that in the chat. All right, so we have 0.02499 moles of CO2 and then 0.249 moles of H2O. So the way that we're going to do this is basically 1 mole of H2O is equal to 2 moles of hydrogen. These are just mole ratios. 1 mole H2O equals 2 moles H equals 1 mole O. You can do the same with the top. 1 mole CO2 can be 2 moles of O and 1 mole of C. So what we can do now, 1 mole of CO2, we're at 0.02499. So let's divide 1 divided by 0.025 to get 40. So we're just going to multiply everything by 40. So we have 40 moles of C, 80 moles of O. Let's do the same at the bottom. We do 1 divided by 0.25. We get 4 moles of H2O, so 4 moles of O and 8 moles of H. Now we need to divide everything by a common number. Everything is divisible by 4. So we would divide our C's. So we have 10 moles of C because we divide 40 divided by 4. We get 10 moles of C. 80 divided by 4, we have 20 moles of O. The O's aren't as important right now. And then we have 4 moles of O divided by 4, 1 mole of O, and 2 moles of H. Now we're just going to put these numbers together, ignoring O. We have C10, H2, and then to find that O, we are going to subtract our greater number of O's minus our smaller number of oxygen. So 20 minus 1 oxygen equals 19 O's. So we have C10, H2O, 19. And that is our empirical formula. I know that was a lot of steps to solve that problem. So if you are confused at all and it was something different that we haven't done before, if you are confused even a little bit on any of the steps, let me know and I'd be more than happy to help. But that is a kind of different way to work on combustion practice, but also empirical formula and some problem solving skills with unknown compounds. So I think some great practice. You get a lot of skills all in one, but definitely a confusing problem. If you're in an entry-level chemistry class, you probably won't have to expect something like this. But if you are in one of those more difficult chemistry classes, this definitely could be a possibility of something that you get on an exam, on a homework assignment. So, if you're just now joining, it is so great to have you. My name's Allison. I'm hosting this Chegg Stoichiometry Office Hours session. We're doing chemistry, math, a little mix of everything. So, I encourage you actively participate, ask any questions you have. Don't be afraid. No question is a dumb question. And it's just so great to have you. So, let's move on to the next question until we get a few more in. So we have 3 moles of magnesium plus nitrogen yields magnesium nitrogen. And if 4.86 grams of magnesium reacts with 2.80 grams of nitrogen and 6.10 grams of Mg3N2 is collected, what is the percent yield? This is a fun question. Kind of easier, definitely easier than the last one, but still a little bit of problem solving involved. So I'm going to give you guys 30 seconds to figure out what you would do about this problem and how you would start to solve it. Your time starts now. All right, 10 more seconds, guys. How would you go about solving this problem? 3, 2, 1. All right, first, what we need to do is find the limiting reactant. I know we already went over it, it's no fun, but we do have to find that for this problem since we don't know what the limiting reactant is. And we want to figure out how much can actually be made. So, first step, we're going to start with these values. And we're going to find out moles of Mg3N2 created or made. So I do 4.86 grams of Mg, 2.80 grams of N2, and we're just going to go to those moles because, again, to convert from one compound to another compound, have to have that mole as the center point. If you get lost at any point or you have any questions, don't be afraid to type in the chat and ask some clarifying questions. I'd be happy to answer them for you. Then we want to go from moles of magnesium and moles of nitrogen to moles of our product, which is Mg3N2. I believe it's trimagnesium dinitrogen. But don't quote me on that. Naming is definitely something I need to improve on. All right. So we have all of those done, set up, how we're going to solve it. Let's plug in those numbers. So we need the molar mass of magnesium and the molar mass of nitrogen gas. So look at the periodic table for that value with the decimal point. For magnesium, you should see 24.31 per 1 mole. Nitrogen, you have 28.02 grams per mole. Then let's do a conversion, moles of Mg3N2 to moles of magnesium. 1 mole of Mg3N2 to 3 moles of magnesium. 1 mole of Mg3N2. And we have 1 for N2. And so I got all of those from those coefficients up there at the top. And now let's just multiply. So you've got 1 minute. Try to beat me to doing these multiplication and division problems. Your time starts now. And if you get stuck or you want to check your answer because you solve it quickly, you can look on up at the board and you'll see what the correct answer is. About 30 more seconds. 5, 4, 3, 2, 1. If you got 0.067 for the top one and 0.1 for the bottom, you are correct. Great job. So these values, knowing them, what is the limiting reactant? It would be our magnesium because it creates less product. So magnesium creates less product. That is our limiting reactant. And now we want to figure out percent yield. Since the problem gives us grams for percent yield, I would suggest converting the moles we just calculated to grams. You can find percent yield in moles or grams. It should be the same because that conversion of how you would do molar mass would be the same. But I think it's just going to be easier to go ahead and convert this 0.067 moles of Mg3N2 to grams of Mg3N2. So let's find that molar mass. You're going to have 45 seconds. Find that molar mass of Mg3N2. Your time starts now. So find that molar mass of this compound. All right, anything you can tell me about it? Any way you can figure out the molar mass? Let me know. 3, 2, 1. So you should get moles of Mg3N2 on the bottom, of course, and then grams on the top because that's what we're converting to. 1 mole, we have 100.95 grams. So let's do 0.067 times 100.95, and we get 6.76 grams of Mg3N2. Hopefully that made sense how we got those grams. And now we want to find our percent yield. So what we just calculated was our theoretical yield. Theoretical because we use limiting reactant, which is like the best case scenario if all the limiting reactant forms product. And we're going to do 6.10 grams. So percent yield, just for a little math kind of lesson, percent yield is actual over theoretical times 100. 100%. That's why it's the times 100, just to get it in percent. So we would do 6.10 grams over 6.76 grams times 100%. And we put that in the calculator. We get 90.2%. Hopefully that made sense how we got that. If you have any questions, feel free to ask them in the chat. That was a nice little percent yield, refreshing question. Definitely easier than the last one. We have about 6 minutes left of this live stream. So if you have any final questions, I encourage you, now is the time to ask those questions so that I can help you and be a resource for you. Till we get some of those questions in, let's move on to our next question, which is, in a titration, 25 milliliters of NaOH solution neutralizes 31.45 milliliters of 0.25 molar H2SO4. What is the concentration of the NaOH? So I'm going to give y'all 45 seconds to tell me how we would go about solving this problem. Your time starts now. I encourage you with this problem, don't overthink it because it's going to be super easy to overthink. How do I solve this problem? This seems kind of confusing. What's a titration? Don't overthink it. You definitely know how to solve it. It's pretty straightforward, and I think it's only going to be like one step. So no reason to get scared by this question. We all know how to solve it. You've got about 15 more seconds. All right, 3, 2, 1. So, just for some background on what a titration is, I'm sure you've probably done one in a chemistry lab if you've had it. I know my freshman year chem lab, we literally just did like 8 different titrations. That was all our lab was. But a titration is where you put the base in like a little beaker, and then you have that long little tube that you put the acid in, and you try to like let it out drop by drop, and you try to make your solution very light pink. And if you overshoot the titration, it's like really bright pink, and you think it's so pretty, but your teacher is like, no, this titration is terrible. That's what a titration is if you have that experience. But we have 25 milliliters of NaOH, which is a strong base, and 0.25 molars of 31.45 milliliters of H2SO4, which is a strong acid. Good news about this question is if we can identify that NaOH is a strong base, which it is, and H2SO4 is a strong acid, which it is, it's a really straightforward, just dilution question. Because strong acids and strong bases cancel each other out, all we have to do is kind of set up a dilution equation to figure out how much the molarity of the NaOH is. Now, if this was a strong acid and a weak base, or a weak acid and a strong base, there'd be several more steps that we need to take into account. But since it's a strong acid, strong base, that's all we need. And we just do that dilution. So if you don't remember the dilution from earlier, it's M1V1 equals N2V2. So our M1 is going to be a question mark because we're trying to figure out the concentration. Our V1 now is going to be that 25 milliliters. I'll label it so that we can all see what we're talking about. And another thing is with dilution equations, this isn't common knowledge, but if you don't have to make a certain unit for the volume as long as it's the same. So it can be milliliters, it can be liters, it can be gallons. As long as it's the same, it is fine. You don't have to convert it to liters. I had one teacher who told the students they had to convert everything to liters, which isn't correct. It'll save you a lot of time if you know it doesn't have to be the same. Now, for M2, we have this number right here because it's that molarity. So 0.25 M. 0.25 M, and then can you find out where that volume would be? That would be right here, right? So 31.45 milliliters, and then we just want to solve for that question mark. You're going to have 30 seconds to solve for the question mark. If you're needing help, you can look up at the board and I'll be solving it kind of step by step. So we have 7.86. All right, again, if you're stuck, look up at the board. All right, so if for the titration problem you got, wrong units, you got 0.3145 molarity, which molarity is just moles per liters. That is the correct concentration of the NaOH. Again, I do want to reiterate that because it is a strong acid and a strong base, that's why we can use a dilution equation. If it's not a strong acid and a strong base, you're going to have to do a lot more converting to figure out that molarity. You're going to have to go from moles times your liters to get to moles and then convert to moles the NaOH. Just gets super confusing. It's not something that I think you guys can't do, but just remember, if you want to solve a titration problem like this, it has to be a strong acid and a strong base, okay? So we are at our time for tonight. It was so great to have all of you guys on the live stream. I'm so glad that you guys can make it. If you are wanting to hear about more live streams this week or more about Chegg in general, you can check out that QR code in the top left corner. We offer live streams for calculus, chemistry, organic chemistry, algebra, anything you can think of, check it out up there. I know it's final season, lots of tests, prepping for the end of the year. So good luck to you guys. I know you're going to do great. We won't have this live stream next week, but the next week we will be back. So any questions you have, come prepared. It was great to have you guys again on the live stream, and thank you, Chegg, for putting this together to help us all learn. And I hope to see you next time. Bye, guys.